Hello, you're welcome to today's class, Kinetic Theory of Matter and Gas Law. Of course, you know that these kind of questions here before us are majorly from gas law. Then let's look at these questions and solve them. Question number 1 says, calculate the pressure at 27 degrees Celsius of 16.0 gram of oxygen gas occupying 2.50 dm cube. Okay, now let's write our solution to these questions. Of course, you can see question number 2 there, that is B. You can see our question number 2 there, but let's write our solution first. Okay, now let's write out the parameters that are given in question number 1. What are we asked to calculate? We asked to calculate pressure. Okay, take pressure to be unknown. Then what are those parameters that were given? We're given temperature. Okay, take temperature to be equal to what? 27 degrees Celsius. Then, we can convert this degrees Celsius to what? To Kelvin. So, converting from degrees Celsius to Kelvin, what will we do? We had 273. So, I will add 273 to 27. That is 27. This will become what? This will become 27 plus 273 degree. Everything, they will give us what? Everything will give us 300 Kelvin. Everything will give us 300 Kelvin. Okay, so that is for temperature. So what other parameter they were given? We're given mass. That is, mass of this oxygen is what? The mass of oxygen is given to be 16.0 gram. Okay, and we're also given the what? The volume to be what? Volume equals to what? 2.50 dm cube. All right. Then, which formula from the gas law can we say it relates or combine these parameters, or let me just say most of these parameters? Which formula can we say combine most of these parameters from the gas law? Is what? This ideal gas equation. That is, PV equals to what? nRT. Okay, now the pressure is what we are calculating for. Okay, the volume is given, which is this 2.50 dm cube. The mole is not given, so we need to calculate mole. Okay, but the gas constant, that is our R, is given, which is this. The temperature is given, so we need to calculate the mole before we can calculate the pressure. Okay, so what do we need to calculate the mole? To calculate the mole, we say that what? Mole equals to what? Mass over molar mass. Do we have mass in the question? Yes, the mass is what? 16 gram. 16.0 gram over what is the molar mass? As in, what is the molar mass of oxygen? Since it is gas, take note, since it is gas, oxygen, this is oxygen, right? This is oxygen atom. Why this is oxygen what? Oxygen molecule or oxygen gas. Okay, so if the atomic number of oxygen is what? Is 8. Why the mass number of oxygen is what? Is 16. This for oxygen atom. What about oxygen gas? It will be times 2 of this. So if this single oxygen has the mass number of this, what about the combination of 2 oxygen? Because it is oxygen gas from the question. So the 2 oxygen will now have a mass number of what? 16 times 2. But the atomic number remains the same. To have a mass number of what? 16 times 2, that is 32. So our mass number is equal to what? 32. Which is also the same thing as molar mass. So if I divide 16 divided by 32, what would that give me? That would give me what? 1 over 2, that is 0.5 what? 0.5 mole. That is 0.5 mole. That is for the mole of what? That is the mole of oxygen. Now we have gotten the mole. The volume is given. the gas constant is given, which is this. The temperature is given, which is this. Then we can substitute these parameters into this equation to get the value of what? To get the value of pressure. So our pressure, let me write the equation here. PV equals to nRT. So from here, if I make pressure subject to the formula, what will I have? I will divide by the V, right? Divide by V, divide by V. This will cancel this. So for pressure, we have what? Pressure equals to what? nRT over what? Over V. Then what is our N? Our N is equals to what? 0.5 times. What's our R? Our R is equals to what? 0.0820 times. So what is our temperature? Our temperature is given to be Kelvin, right? Okay. Our temperature is given to be 300 Kelvin. 300 all over. Well, what is our volume? Our volume is given to be what? 2.5. So from my calculator here, I will multiply the numerator. I will have what? 0.5 times 0.0820 times 300 times 300. So this will give me what? For the numerator here, we have 12.3. Yes, I will have 12.3 over what? Over 2.5. So this will be 12.3. That is my answer divided by 2.5. This will give me what? 4.92. 4.92. So my pressure is equals to what? 4.92. But now I will show you something here. For you to know what the pressure is all about, for you to know the units. The unit is ATM. Why is it ATM? The unit is ATM. Why is it ATM? The gas constant, if you look at this gas constant is in what? ATM. You can see that all this, if you look at all these parameters, our mole, this is our mole. Our gas constant, this is it, okay? Our temperature is in Kelvin. It tallies with this. Our volume is in dm cube. It may be dm cube or liter. One dm cube is the same thing as 1 liter. So our volume match with this, okay? And then our pressure as well must match with this, okay? So that is our final answer for pressure. So let's calculate the second question here. That is the B part. So to calculate the B part, then let's write out the parameters given. Then we're given what? What are we actually asked to calculate? How many moles of oxygen? Moles. So let's take the moles to be unknown. Moles of oxygen gas are there in 350 cm cube of the gas at 0 degrees Celsius and 380 mmHg pressure. Student can easily get confused here, but pay attention to this. Now we are calculating mole. Take the number of moles to be what? To be unknown. Then let's write out other givens. We're given what? Volume. And this volume equals to 350 cm cube. But now, if I'm working with this gas constant, my volume must be in dm cube, as you can see here. My volume must be in dm cube, as you can see here. So I have to convert this centimeter cube to what? To dm cube. To convert from centimeter cube to dm cube, I will divide by 1000. This will be 350 over 1000. So this will give me 0.35 dm cube. All right. So we're also given temperature. Temperature is equals to what? 0 degree. But the temperature here is in degree or Kelvin. Is in Kelvin. So I will have to convert this degree to Kelvin. And why converting from degree to Kelvin is same thing as we had 273. So this will be 0 plus 273. If I add them together, it will give me what? 273 Kelvin. Okay? I'm also given what? Pressure. Pressure, that is our P, is equals to 380 mm what? Hg, that is millimeter mercury. But if you look at the pressure here, is it in millimeter mercury or ATM? It's in ATM. So we have to convert this pressure to what? To ATM. So to convert from millimeter mercury to ATM, I will divide by what? I will divide by 760. 760. So this will give me what? If I divide this by this, I will have 0.5. I can decide to put 0 at the back. I can decide to leave it like that. Let me just leave it like that. It's 0.5 ATM. Then we're given the gas constant itself, R, to be equals to what? To be equals to 0.08 0.0820 ATM dm cube mole per mole, that is per mole, per Kelvin. Okay. All right, let's solve. From our ID gas, PV equals to nRT. This is what we are calculating mole. So to make mole subject of the formula, I will divide by RT. Divide by what? RT. RT here, we cancel RT. So N, that is number of mole, equals to what? PV over RT. So what is my P? That is pressure, 0.5. ATM, that is ATM, but I may decide to leave it for now because of this space. 0.5 times the volume. What is the volume? The volume is what? 0.35 dm cube. That is 0.35 multiplied with 0.35 divided by R, our gas constant. That is 0.0820 times what is the temperature in Kelvin? That is 273 Kelvin. Oh, I put this unit here. Yeah, you can put the unit, but I'm just trying to manage the space. That's why I didn't put the unit. So I will now put the unit at the end of it. So this should give me what? Now you multiply this and this together, then you divide it by the multiplication by this as well. Multiply this and this, multiply this and this, whatever you get, divide them. Okay, so our final answer, that is number of mole, will be equals to what? 0.00782 mole. Okay, so this is Tutor Ayodele YouTube channel. Consider to subscribe, like, comment, and share to your loved ones. See you in my next video.